Thank you. Thanks to all of you for allowing me to intrude on your day. I know everything usually goes pretty smooth. Lisa, how are you? I call her Dr. Rowe from Langley. I know all of you know her. I've had an opportunity to meet some of you, particularly those from Boeing. I'll single you out because I promised that I was going to use you in a good way, okay, in my comments today. But I want to thank Jawan again for inviting me to come out. Pete, thanks very much to you for providing the facilities and for allowing me to spend just a little bit of time with some of your leadership team. As I said again, I apologize for not being able to spend more time out here, but I will be back. The long history of aviation comes alive out here, and it should be hopefully coming alive again in this conference. As a trained pilot myself, who doesn't fly very much anymore, and so it was really thrilling for me to get over to the VMS and have an opportunity to fly a tilt rotor aircraft this morning. And I've been in the simulator before, but still have not flown the Osprey and probably won't get to fly it. So that was the closest I'll get to a tilt rotor aircraft, but I had a good time. And I did not crash. But I love just being soaked up in this atmosphere. It allows me to come alive because Washington's okay, but we don't do this kind of fun stuff most of the time. I have to say, on the plane ride out here we came in from Indianapolis after having spent yesterday at Purdue. I was daydreaming a little bit about what some of the aircraft of the future will look like. And I tend to do that a lot. And that's why it was really special to have an opportunity to get in the tilt rotor simulator this morning, or this afternoon, I guess, because as I was telling some of the folk over there, I have long believed, since the Marine Corps decided that we were going to go with the Osprey, many years ago, after discovering the XV-15 that NASA had worked on, I remember telling people that this is really the wave of the future. And while we are not there yet commercially, I really do believe that tilt rotor aviation is going to revolutionize a lot of the things that we do. Having served on a board of an oil company, I'll tell you, we have to start evacuating offshore platforms days in advance when there is a threat of a storm or something like that. Something like a tilt rotor aircraft that can travel 300 knots or better cuts the time that you'd have to take to evacuate crews to hours instead of days. So in terms of dollars saved, it's incredible what I think tilt rotor aviation is going to do, not just to that industry, but to the commercial world in general. There are a lot of amazing concepts on NASA's Aero website, and I know there are a lot of great ideas and vibrant imaginations in this room. I hope this summit is productive for all of you as well as for us in NASA, both as individuals and then as the field of those in the field of aeronautics. My plane ride, really my whole airport experience today, it wasn't too bad, believe it or not. But in the future, I think it'll probably be a lot better. Quieter and more efficient flights will mean none of us will have to worry about, that our air travel is polluting the air or that it's polluting the sonic environment of our neighbors. I'm hoping you're all dedicated to helping bring about these important improvements in aviation. Your work here and in the future will have a huge impact. I often find myself having to explain to people the benefits of space exploration to life here on Earth. But in aeronautics, the positive gains from what we do should be a little easier for anyone who has ever walked through an airport and struggled with our air transportation system to see these benefits. Our critical responsibility is to those who feel anxious because of the long distance they have to travel to reach an airport, the crowding they experience upon arrival at the terminal, the departure, en route, or arrival weather, or concerns that the technology on the planes may not be up to dealing with problems that they guess they're going to encounter in the sky. That's why we're so excited at NASA about the opportunities we are being given in the coming years to help develop solutions to some of our most pressing aviation problems and create the next generation of air transportation systems that will last for generations and make us all safer and make the planet a better place. That's a huge challenge, but we at NASA enthusiastically accept it. Just as I like to tell scientists and engineers who send our human and robotic missions out into the cosmos, you are contributing to national goals and helping people in the work you do every day. We're going to make measured progress leading to an ever-expanding accomplishments to meet the myriad increasing challenges. This is our challenge, to shape the future in aeronautics. Over the past 70 years or so, air travel has become one of the world's safest modes of transportation and a vital part of the world economy. But even with this tremendous progress, new challenges continue to surface. It's no secret that our airports and our airplanes are getting more and more crowded. In the United States, 60 certified domestic carriers operate more than 28,000 flights a day. Last year alone, they moved more than 700 million passengers, a number that's forecast to exceed 1.2 billion by 2030. Here's what the sky overhead looks like right now, and that's real. That looks like a traffic jam to me. Just imagine what it will look like 20 years from now with almost double the demand. And imagine the demands on air traffic controllers. Our aging air traffic control systems need new capabilities, new technologies, and new ways of looking at the big picture. As we are doing in spaceflight, we're looking at where we want to be, not just a few years down the road, but decades from now. And we're making decisions about what we need to do today to get there. Today, commercial aviation provides jobs for nearly 1 million Americans. The aerospace manufacturing industry provides the nation with a $60 billion trade surplus. But the capacity of our system to operate the way we do now and the increased traffic's toll on the environment and our system's own infrastructure are factors we need to address. We need to make some changes, both in the design of aircraft and in the way they transit through our skies, to not only maintain but improve safety and efficiency. Yes, I'm going to use a word that has become integral to my vocabulary. We're going to have to innovate. NASA Aeronautics is finding answers to the challenges we face. For decades, NASA has worked to improve the performance, efficiency, and safety of our aviation system. Nearly every airplane that exists today uses technology made possible in part by NASA research. We're present in the innovative aircraft themselves and the air traffic management systems that help make them safe and efficient. When it comes to NASA's contributions to environmentally friendly aviation, the list of technologies we have developed that are in use today is long and comprehensive. The most recent example is the Chevron nozzle. I was talking to my Boeing friends about this. This is similar to the ones that we'll be flying on Boeing's new 787 and 747-8 airplanes. Another thing I'll tell you about this, it's not in my comments, so somebody from Boeing can stop me if I get it wrong as the Dreamliner's taxiing out there. When we were in Farnborough for the Farnborough Air Show, I got an opportunity to look at that airplane up close and personal and the Chevron nozzles, and as we were standing there, they were explaining to me about the memory alloy of which the nozzles are made. We in NASA are very proud of it because we can't take all the credit, but I was incredibly proud to see that Boeing had decided to use that type of technology in the nozzles themselves. For those of you who may not know what it does, it's an alloy that has a memory, just as the name implies. And it knows that if I was at this altitude and it was this temperature yesterday, and I got the best efficiency by squeezing down myself to be this size and let the airflow come out like this, that's good. And so as the airplane climbs or descends, the memory alloy actually makes the nozzle move around such that we get the best efficiency out of it. So did I get that close? All right. Boeing guys, was that close? Huh? That's okay? You're going to send me some notes and, okay. We'll get it right, all right? But that's my way of explaining it. I think it's pretty good. we already see the sawtooth shapes at the back of the engine on the aircraft that I just talked about. They reduce engine noise significantly without penalizing engine performance. And as I said before, they are a NASA innovation. In the not too distant future, thanks to NASA, you may be able to live near an airport and not suffer the whine of jet engines revving up for takeoff when you're trying to sleep. Nuisance noise near major metropolitan airports is seen as one of the greatest hindrances to the future growth of the aviation system. So the advent of chevron nozzles like this is especially timely. Another NASA innovation, the little upturned ends of the wings you see here, came about when the environmental awareness and the energy shortages of the 70s prompted demands to save fuel and stop polluting. Winglets reduce drag and fuel consumption, and most of the airlines today have them in service. We want to show that it's possible to reduce aircraft fuel consumption, emissions, and noise simultaneously. Each of these is a lofty goal in itself. We're working on demonstrating the feasibility of technologies that would enable aircraft to burn 33% less fuel than today's most efficient models. We hope to make a lot more progress on those technologies within the next 5 years. With help from aircraft technology and air traffic management techniques developed by NASA, harmful carbon emissions from airplanes could level off and begin to dissipate in just 10 years' time. Our goals are ambitious, all the more so when tackled together, but I'm confident they're achievable. Enabled by NASA research, U.S. companies will begin designing airplanes with unconventional shapes and building them with new, lightweight composite materials and structures to increase lift, reduce drag, and lessen the strain on engines. Now, anybody recognize this? This is an example of a new damage-tolerant airplane material NASA's developing. It's called Perseus. If I really wanted to impress you, I would give you the full name of what the acronym Perseus stands for, but since I really don't want to impress you, then I'm not going to try to remember that, because Beth Dickey tried to teach it to me, and all I remember is one of these S's stands for stitching, and that's probably the key to the technology, how we, when a crack runs into the cross-stitching, it stops it. So again, in a layman's term, that's one of the advantages of the material. Not only will these airplanes look really cool, but they'll have breakthroughs like engines to handle more air, which can be placed in unusual places on the airplane and deflect their sound. Did I skip something there? Because you had a video, I think, that I really wanted people to see, or did you already see it? It was one, we'll do this by, okay, I don't want you to miss anything, because I had some futuristic airplane stuff here that I wanted you to see. And so I'll stall for time while they try to find it, okay? I don't know whether that's it or not. Okay, here we come. And I'll, that's the Perseus. Good, okay, you saw the big Perseus. And then here's some of these imaginative airplanes I was talking about, okay? These innovations will help us capitalize on the potential of alternative fuels and advanced power technologies. We'll begin equipping aircraft cockpits with automated decision tools and satellite-based air traffic information and communication systems to let airplanes climb or descend without interruption and fly more direct routes to their destinations. This stuff's really fun, so, enjoy it. I'm watching a movie, okay? That's why I keep getting distracted. You can go through that one. You did that one, so. You can go to the next one. There we go. I showed you the current state of affairs a few minutes ago. Here is what the future of America's airspace system could look like. The system is elastic. Distributing the air traffic control burden between the airport tower and the cockpit allows maximum flexibility. The system expands as necessary to accommodate demand, not only for everyday transport, but also for new missions by very different kinds of aircraft, even some without pilots. Ooh. NASA didn't achieve any of its past breakthroughs in aeronautics alone, nor will we achieve any of the future breakthroughs by ourselves. Our partnerships with other government agencies, industry, and academia are crucial to our success. In partnership with the Federal Aviation Administration and the Department of Defense, for instance, NASA is developing safe and efficient air traffic management and operational procedures using satellite-based navigation aids for the air traffic control modernization effort known as the Next Generation Air Transportation System, or NextGen. Another example close to my heart is our work to solicit fresh ideas from industry and academia through NASA research announcements, student design competitions, and internships, all of which provide support for university science, technology, engineering, and mathematics departments. We've also just opened the application period for this year's aeronautics scholarships for undergraduate and graduate students, and we look forward to helping to jumpstart the studies and the careers of these future leaders. Our close collaboration with our stakeholders helps us ensure that we are working on the right challenges, that our research is both relevant in the aviation community and beneficial to the flying public. NASA is fortunate. There's a strong public support for aeronautics research, as evidenced by the recent budget increases approved by Congress. The President has requested another increase to almost $580 million for NASA aeronautics in 2011, and Congress appears to be supportive of this. The President's budget strongly supports our existing portfolio of research and development and the timely development of NextGen. With Congress's approval of this increase, NASA will help expand our system's capacity and focus on work to enable fuel-efficient flight planning, reduce the overall environmental footprint of airplanes, reduce delays on the ground and in the sky, and improve the ability to operate in poor weather conditions while maintaining the current high safety standards of our aviation system. Our efforts will facilitate the transition of new capabilities to manufacturers, airlines, and the Federal Aviation Administration for the ultimate benefit of the flying public. NASA Aeronautics has a long and prestigious history of vital contributions to America's aviation community. Green may be the new hot topic in the 21st century America, but the principles of environmental responsibility has guided NASA's research goals since the earliest days of aviation. This summit celebrates technical excellence and the power of partnerships in advancing U.S. preeminence in aviation. You will see not only the depth and breadth of NASA's green aviation research, but also the scope of NASA's commitment to clean, quiet, efficient, and safe air transportation and a better quality of life for all. We need your excitement, your dedication, and your innovation. With your help, NASA will continue to be a springboard for technological breakthroughs, advances that bring incredible aircraft into being and change all of our lives for the better, even when we don't see the complex systems behind our travel. And we'll do it in a responsible way, a way that makes us good stewards of our environment and the world. Green is much more than a buzzword to us. It's part of every bolt we turn. I congratulate you on all your outstanding achievements and look forward to many more in the coming years. And I'll be thinking of you every time I board that airplane for my next trip, which seems to come pretty frequently. Godspeed as we tell the astronauts, and thank you all for being here. Thanks very much.
We have about 5 minutes for questions. If anyone would like to ask the administrator a question, let's do as we did this morning. Please raise your hand. We'll get a microphone to you. Wait for the mic and tell us your name and your affiliation. Any questions here at Ames Research Center? Here's one in the front.
And if they're really hard, I brought my driver, because even my driver can answer the hard questions. Not really.
Doctor, it was a very good presentation.
Thank you.
Very entertaining as well as educational. I'm K.R.S. Murthy, President of Silicon Valley Engineering Council, council of all the engineering professional societies, as well as a solar company CEO. What we need is a software programmable composite material. in addition to being a memory alloy, memory alloy has its limitations in terms of programmability, and a software programmable composite would be the ideal one going forward in terms of materials, advanced materials. Anything else in similar lines that is there in the advanced materials that NASA is working on?
You know, I really am going to refer you to somebody, and I'm going to ask, I don't know whether Jaywan has an answer. I don't know the answer to your question, but
okay.
I think what he's asking is, are any of us working on software?
Yeah, eccentric materials,
okay,
which can be software programmable.
I will throw that question out because I don't know the answer. Okay.
So what we've done is we've broken the program down into 3 parts, a near-term, mid-term, and longer-term part. So I think what Mr. Bolden showed us, this new Perseus material, is sort of near-term or mid-term. The question you ask is more of a long-term nature. A lot of development time needed for such a material system that you're talking about. We do have a small effort in nano materials. We do have, as far as people thinking about programming nano material or morphing material into shapes via computer software. I'm not aware of any groups within NASA that are doing that. I know it's an emerging area of interest, but we don't have a very large effort in that area.
Any universities represented here? Just out of curiosity? One back there? You know, two, okay, at least. As I said, I was at Purdue yesterday, and I was, I thought I had a feel for what they were doing. They are really, I mean, doing some incredible stuff that I would have never imagined. Some of it is really way out there. My guess is what you're talking about is probably going to come from a young researcher on a university campus. People my age don't even think about it, to be quite honest. We have, through the Office of Chief Technology, if our budget goes through the way we want it, we want to be able to award 500 full scholarships for graduate and postgraduate work in technology and technology development beginning next year. And some of you may have already received queries from us trying to find out what are the areas that we need to award those, in what areas should we award the scholarships to be relevant to you. Because I think as we get more money back on university campuses, we are going to find the answers to some of the things you suggest. But yeah, okay.
Any questions here at Ames? Here's one on this side. Mike's coming.
Hi, it's Tom Hicks from Boeing. I'd just like to hear you speak a little bit more about the value long-term about partnershiping with industry and how that benefits both sides.
You know, Tom, is it Tom?
Yes, Tom.
I got it right? Okay. The thing is, the way that NASA has come through the years, even from its NACA days, has been an incredible partnership with industry. Some of us have forgotten that. And I think if we look at where we want to go in the future of human spaceflight, the only way that we're going to be successful in doing what President Obama has charged us to do, and as he understands, is that if we get back to forging that partnership such that we work collaboratively with each other, that we share ideas with each other, and that we, even when we think of new technologies and new ideas, we turn to you to actually take it through to fruition, because that's not what we do. We get in trouble, when we try to isolate ourselves from industry and pretend that we do those things. We do need to have engineers who are capable of going to any manufacturing floor, and overseeing a project if need be. But the partnership between industry, academia, and NASA, and our international partners is really going to be critical. We don't see quite as much of it in the field of aeronautics because of some export-import laws and the like. But even there, Jaywan, in his travels internationally, we're trying to find better ways that we can collaborate with some of our international partners. We're able to do it a little bit better in science than in anything else. But in aeronautics and even in human spaceflight, it gets to be difficult sometimes because of the export laws and restrictions, but the Congress and the President and the Secretary of State and the Secretary of Defense are working really hard to get some of those things eased, if not turned off. Okay. Hope I answered your question.
Okay, we have time for one more question. Anyone? We do not appear to have any questions on our virtual network either. One last chance here at Ames.
Then I have one question. It is not a rhetorical question. And that question, as I kind of implied in my comments, is will you all help us? You know, we really need ideas, whether it's in aero or science or human space flight, because we don't have a corner on the market. I have an incredibly talented group of 18,000 plus young men and women. And young, I'm young, okay? Because I feel incredibly young. My body tells me sometimes that, you know, don't believe it, but I feel young. And so when I use the term young, I mean everybody in this room and everybody who's back at the NASA centers. We have a lot of ideas, but we don't have a corner on the market on the best ideas. So we really need for you all to make that collaboration, you know, that Tom asked about, to make it real. It's one thing to say we want to collaborate, but if you don't come to us and put demands on us and tell us what kind of facilities you need, because we're going through a very difficult time now in trying to decide, you know, what do we have to have in NASA in terms of infrastructure. We are oversubscribed, overpopulated, over everything. If you talk to anybody representing any of these centers here, or you talk to J1, we would love to keep everything that we have because we figure one of these days somebody's going to need it. Well, we can't do that. And you all probably know as well as anybody what you foresee coming down the road in terms of technology development and the facilities that are going to be required to take the ideas to fruition. So talk to us. You know, if there's something that you need to let us know. If there's something you see no need for, particularly in the area of facilities, then let us know because it will help us with our decisions that we have to make in the next year, to be quite honest, if we're going to be able to fund the kinds of things that we want to do in the future. But thanks very much for letting me spend the time with you, and thanks so much for participating in this conference.
Thanks.
Thank you.